Good evening, everyone. Is my slide visible? Hello, am I audible to all of you? Hello, am I audible?
Yes, yes.
Okay, thank you. So we'll get started with today's class. Uh, so I am Manikandan, a PMR scholar from IIT Bombay. So this is tutorial 6 on the course Joy of Computing by using Python. So this week in this lecture we'll cover some practice problems based on the contents of week 6 of the course. Okay, so as usual we'll start with some quiz, and here is the first question. So I'd like all of you to try this. So a statement is given that returns a character at the location I ahead of the alphabet alpha, which is given as an input, and returns B. So what will be the output of this code? Okay, so there is this function ORD. So is everyone familiar with this function? So is the question clear to everyone? There are some new functions involved here. There is this function ORD and there is CHR. So if you are not familiar with these functions, please let me know. Okay. So this function ORD, what it does is, if you supply an alphabet into it, it will return the ASCII value corresponding to that alphabet. Okay, so if we supply A, the ASCII value of A will be given as output. Okay, so alpha is an alphabet that is applied to the function So when I supply a, it will return an ASCII value that is an integer. Okay, so this I value could be the increment that I want to add. For example, if I takes the value 1, so it will be ASCII value of 1, ASCII value of a plus 1. Okay, so ASCII value goes in the increment of 1. So ASCII value of a plus 1 will be ASCII value of b. So what this CHR does is it will convert the ASCII value into alphabets back. Okay, so let's say the ASCII value of a is okay, so let's suppose ASCII value of a is 64. So ORD of a will return 64 as the output. Okay, so when I add 1 to, so I'm trying to evaluate this expression ORD of a plus 1. So ORD of a plus 1 will be, that is clearly 65. Okay, so now I want to convert this ASCII value back into the corresponding alphabet. So character of 65, so that will be b, which is the ASCII value of which is the alphabet corresponding to the ASCII value 65. So for clarity, okay, so is the explanation clear to everyone? So ORD and CHR, these functions are inverses to each other. So one converts alphabet into ASCII value and the other converts ASCII value into alphabets. Okay, so let's say if I do this operation, CHR of 64 will get back a. The recording of this meeting, I'm live streaming this in YouTube, so you can find it there. I can attach my link to the channel. Just a second. So I have attached the link to my YouTube channel. So every week I'll be live streaming the lectures. So if you want to revisit the lectures, you can always check out my channel. Okay. So that being said, so this is the logic behind this question. So when we go into the details of the code, we are defining a function encrypt, that is taking a sequence of letters as an input and a key, another variable key. Okay, so key is of the type, when we call the function, the letter body is a sequence of alphabets and key is an integer, 4 is applied to it. Okay, so an empty list L is created, and for each element in the list, this alphabet list, we are doing this conversion of converting the each alphabet into its ASCII value and adding 1 to it, and then reconverting the ASCII value into corresponding alphabet. Okay, so it's the exactly same operation that I have done here. So A will be converted into 64 and we are adding 1 to 64, it is 65 now, and we are converting 65, the ASCII value of B, back into its alphabet B using the CHR function. Okay, so and after this conversion we are joining the each element to the empty list L. Okay, and the list is returned by the function when the function is called and captured in the in this list D. So when we print D, all we get is this kind of conversion to each of the letters in this sequence. So every letter is incremented by 1. So it will be B, C, D, E, F, G, H, I. Because our input, whatever this A to H, these alphabets, they are added by, we are incrementing it by 1. So we cannot add 1 to an alphabet because alphabet is a string type variable and 1 is an integer. So we cannot do addition of a character and an integer. So we are converting a character into its corresponding ASCII value, and then we are doing this increment operation. So the basic concept is simple.
So what are that 4 parameter is given there in encrypt? D is equal to encrypt letter body, comma 4. That 4 is for what purpose?
4. Okay, it's a good question. 4 is not used anywhere. It's just for each list in ITR letters. There should have been some use for 4, but
in the definition of encrypt, when key is letter and key, though 2 parameters are there.
Yeah.
So letter is letter body and that key is that 4. So we have to increment each alphabet by 4 values. So the answer will be E, F, G, H, I, J, K, L, I think.
No, so we are incrementing by 1, so that is defined here, right? The ASCII value of each alphabet in the letter body is incremented, its ASCII value is incremented by 1. So this 4 is misleading, so this is a catch. So this 4 does nothing. This key has no significance in this part of the code. If you check line 2 to 5 where the function is defined, this key has no value. So that is a trick to confuse you, because we are giving 4. Obviously we will think that so everything is incremented by 4. I'll check option 3, but so that is the catch in this question. If you look carefully in the code, all we are doing is incrementing it by 1. Every ASCII value in the list in the letter body is incremented by 1. Okay, so this 4 is it's a trick just to confuse us. It is not used anywhere in the definition of the function. Okay, so please don't be confused with that. All we are doing is incrementing each alphabet's ASCII value by 1 and then converting back into the alphabet. Okay. Small mistake. ASCII value of B is 65. Okay, so try to solve the second question. What does this following code do? So there's a function guess that takes an input number num. So when it is called with the value of 10, what does this code do? Yes, return is not there. So it's not necessary for a function to have return. Sometimes the objective of the function is to print something, that's all. Okay, so it would appear that option 1 is the correct answer, but actually it enters an infinite loop. So that's because there is no break statement here. So once this function is called guess 10, the control will go from line 8 to this. It will evaluate statement. So control will go like here, it will ask for an input. It asks us to guess a number. So it is checking whether the number given by us is equal to 10 or not. If it's equal to 10, it's printing success. Otherwise it is going again to the calling the function. Okay, so the catch in this is, even if the number guessed by us is equal to 10, even after that the control flows back here. So after here it goes back here. So there should have been a break statement after this print statement. Otherwise this flow of control will go like this. It will keep on calling this function again and again, and it will print success so many times. If we guess the number as 10, it will keep on printing success. If our guess is some other number, it will keep us to keep guessing a number until is equal to 10. If it's 10, it will print, but it will be in an infinite loop. It will again ask us a number, and then it will keep on printing success. Okay, so there should have been a break statement after this. So writing is hard. Okay, there should have been a break over here. Okay, so I hope this is clear. Now try the third question. So what does this following code do? It uses a random we are importing the random library, and we are defining a function guess.
Sir, can you show the previous question for a second? I forgot to take a screenshot.
Sure.
Thank you, sir. I've taken it now.
Okay. So if you want to follow the slides, like I have shared a Google Drive folder with you. So all the week lectures are updated over there. So if you want to check back, you can refer the slides also.
Okay, sir.
Yeah. So all of you try this question and let me know what is the answer. So this question is similar to the last question in some sense, that it is also asking for a guessing a number. So the guess is automatically generated from a random list of integers 1 to 100. We are picking one of the integers. Okay, so that is applied to the function as an input. So num is the randomly generated integer that is between 1 and 100, and there is a user defined input a, which is asking us to guess a number between 1 and 100. Again, we are printing both the numbers, and there is a conditional: if the user defined input is same equal to the randomly generated number, we are printing success, otherwise we are returning to the guess. So it is recursively calling the function. So recursion, I hope all of you are familiar by now. So the function is calling itself inside the function. Okay, so the function guess is called inside the definition of guess itself. So this process of guessing will continue, and based on the value of the user defined input, we'll print success, or else we'll continue the guessing. So we can eliminate the statements which don't make sense. So this is not true. Option 1 is not true because there is no break, and this is not true. 10 is just a random number, so we cannot be sure that the guess is 10 and what we are giving should be equal to 10. So this doesn't make sense. Okay, so 10 is very one of the possibilities out of 100 guesses that we do. Okay, so anyway, even if we are the random number is 10 and our guess is also 10, even then this option won't be true because there is no break statement here, just like in the last case. So, and option 2, the computer generates a random number r and keeps it. The user is repeatedly prompted to enter a number. If the user enters r, this also says that once the user defined input is same as the guessed number, the randomly generated number, the code says success and ends. Otherwise the prompting is continued. This is also false. This would be true if there was a break statement here after the success printing. Okay, so this is not true. And considering option 3 and 4, so once we consider the option of entering an infinite loop, we should consider the definite case where the computer is generating a random number r and then keeps it. The user is repeatedly prompted to enter a number. Okay, if the user also enters r, the code says success, else the computer generates a random number r and thereafter prompting is continued. Yes, who has a doubt?
Sir, show that code again, so please.
Yeah.
Okay, thank you, sir.
Yeah. Okay, so option 4 would be the right option for this. So this has the else case, right, that the computer generates a random number r and then the prompting is continued.
Why that infinite loop option is not correct?
So it is not an infinite loop because so this is virtually saying that this prompting is continued means so you are prompted to enter this user defined number again and again. Okay, so it's not going to print success infinitely. Every time this random number generated will be different, and the guess given by us will be it's not same all the time. So in the last question we had a fixed number 10, and once 10 is equal to a certain number, the condition would be always true and it will keep printing success infinitely. But here the every time the random number generated is
Okay.
you get it, right? So it's not necessarily equal all the time. It's a random process, so we cannot confirm that it will enter. So virtually it is the prompting is continued in a random way.
So in the last question, wasn't the recursive case in the else part in question 2?
Yeah, there is a recursive case, but
So why would it be an infinite?
But this is not random, right? This is not random, so it is like it will always keep printing success, and it will be a infinite times the success will be printed. So over here it is like it is prompting us every time, and there is a random number generation every time, so we cannot say that always it is a success.
So, but if we print 10, if we guess 10 once in the previous question, it will just print success once, not infinitely.
No, I'm saying that so once you know, so it is always calling with num is always 10, right? If it is calling in this way.
Yes, sir.
Yeah, so if it is printing success, the control is going over here, so num is again 10, and we know when 10 will be, so we know what our number is.
So, but after printing success, the function is not getting called again.
After printing success, the function is, so that's what this break statement is missing, right? That is the issue here. So it is recursively being called, right? Yeah, so if you just follow the control is like, the control flow is like you have a function definition, you are calling it, and it does something. After the control exists, it's like it's going back here.
Yes, sir. Got the difference between two infinite cases.
Yeah.
Both are the infinite cases, but it is specifically appropriately defined in last option.
Yeah, so over here it's there is a random number generation, so we cannot say that these two algorithms are equivalent. So for this we can say that we know which number should we guess to get into an success case always. But over here we don't know because it's a random number generation all the time.
In first case, work of a function is finished. Still, it is again and again asking. So it is infinite loop. But here, it cannot be said that the task is completed, because for different times, it will generate different numbers,
Yeah,
and,
yeah.
and you may ask correctly infinite times. That is not infinite loop.
Yeah, this is not infinite, but it's just that the prompting keeps on continuing.
So the same infinite condition, but described appropriately in last option here.
Yeah. So this kind of so this in this case we can say that success won't be printed infinitely. Instead, it will. There is a proper
Sir, I
prompting every
think the
time.
difference is in this question, when we are taking the input, we are converting it into an int. So there is a chance we will get to the success case. But in the previous question, we are not converting the input into an integer. So we never get the success case. The equality is never satisfied. So we never get to success case. That's why it's an infinite loop. The input is getting it as a string.
Yeah, right. So okay, the typecasting is missing. Yes, you're right. So sorry, it's my bad. So this is always a string. Yeah. Yeah, so this is always a string, so the else case will be called all the time. Sorry, it's my mistake. So because in this case the control will flow always to the else part, because this is string and this conditionality will never be satisfied, so it will go here.
Yes, that observation is also very correct. And
Yeah,
that is the correct reason of
this is
infinite. Yes.
so yes, this is the thank you. So I was getting it wrong. So yeah, okay, so that's why over here this int conversion is there. So when it success, it ends. Otherwise, this prompting is continued. This random number generation is continued, and this prompting is continued. So yeah, thank you.
Welcome, sir.
So question number 4. So this is a simple one. So again, recursion is followed using the concept of recursion. There is a multiplication function defined. So what will be the output of this? Okay, so this one is straightforward. So a function mul is defined, which takes an integer number num as an input. So we are giving a user defined n, so that is an integer that is applied to this function mul. Okay, so when calling this function, if n is equal to 1, if this n that is applied as captured as num, if num is equal to 1, it will return -1. Otherwise, it is recursively doing this process. -1 times multiply num -1. Okay, so if you do this with an example, it will be much clearer. So let's say n is equal to 3. So if n is equal to 3, what it does is, so I'm supplying n is equal to 3, control will go here. Okay, it's going to the function definition. So num is not equal to 1 because I'm giving 3. So what it does is, from here it will go to line 4. So it is returning text box. Okay, so what it returns is -1 times mul of 2. Okay, so if I call mul2, so this is like a recursive function, so that will be -1 times -1 of mul1. Okay, and now num is equal to 1, it should return -1. So mul of 1 is equal to -1. So this will be same as -1 times -1 -1. Okay, so this is equivalent to -1 raised to n, isn't it? So because of this kind of recursive calling, we can conclude that option 3 is the right answer. Okay, so this is our anchor case. So this is our base case when num is equal to 1. So till then we have to recursively call that function. So our recursive case will be satisfied here. The anchor case is the mul of 1. Okay. Till then recursion proceeds. Okay, so I hope that's clear to all of you. Now try question number 5. so there is a function defined search that is taking three inputs. One is a list, and one is a location, and one is an item. So the control starts from here. We are defining a list, and that list is applied to the as an input to the search function. The other two inputs are location equal to -11 and item is 3. So if we go in, so this is being called here. So control will go like this. First it will evaluate line 3. Is location less than 0? Yes. So then location is assigned a value of 0. Okay, so L of 0, now location is 0. It is updated to 0. -11 becomes 0 now. Now following the sequence of instructions in line 5, so L of 0 is it equal to item. Item is 3 and L of 0 is 1. So the first element in the array L, so that is checked, is it equal to item. Item is 3, so 1 is not equal to 3. So from here the control jumps to here. So now this is evaluated. So if this is true, that is this location, if this is equal to, so it is checking whether it has reached the end of the list or not. If the location is equal to length of the list -1, that means we have reached the end of the list. In that case, we did search throughout the list and we didn't find this number 3. Okay, then we have to print element not present. So in this case, LOC is still so it takes a value 0 now. Okay, still we are doing the first element, we are in LOC is 0. Okay, so this won't be satisfied. Now it is recursively being called. Now LOC is updated to LOC plus 1. Okay, so again control goes over to the second line, and then this kind of recursive calling occurs until this item 3 is found in this list. Okay, so that is clearly option 4. So we are scanning the list from first to last element, and we are displaying the index of the value that is passed in the last number in the function. Okay, so index of this 3, that will be what? 0, 1, 2. So that will be returned here. So we found item 3 at index 2, that will be returned. So location will be 2. Once location is 2, the function is returned. Okay, so clearly option 4 is the answer. Okay, so this is clear. Now try 6th question. So this is same as the previous question, just that the options are put in some other words. Yes. So the correct answer is option A. So it is performing. It's basically the same code snippet from last question. So what this snippet does is, it is a recursive algorithm for linear search of an element in a list. So binary search is dividing our population into two halves and then searching in one half and then other, that kind of search. So that is binary search. Linear search is searching in a linear fashion, starting from element 1 all the way till here. So if we compute the time cost for binary search and linear search, binary search is much efficient. Okay, so anyway, this code, what it does is linear search. Okay, so the next question. So question 7 is here. So this is pretty simple, just typecasting what will be the output of this statement. Yes, so obviously the answer is option B. So because in typecasting, if we are typecasting floats into integers, so this will be cut and all the decimals are dropped off. So 3 plus 2 is 5. That is option 2.
So input is 5.
Sorry?
We get the output 5.
Yeah, the output is 5. Yes. Yeah. So question number 8. The following code to its best represents a scenario of what? So there are some real life scenarios given in the options. So this code, the code snippet could mimic which of the following real life scenarios? Okay, so there is a recursive call of the function func. So based on what this snippet does, what is the closest real life scenario we can relate to?
So maybe B.
Sorry, can you repeat? Or maybe you can put your answer in the chat box.
Maybe B.
B? Okay. Okay, so others also give your answers. Okay, so some B's and A's. So the right answer is A.
Mm.
Yeah. So this can be equated to a situation where, so I is equal to 0 is I can be the share of cake that we have. Okay, so
No, that's why I have given the answer A, B. I thought that that is question answers. After I by 2 function, that is recursive function is calling. No?
Yeah, recursively we are calling the function, but every time it is being cut into half.
Yeah, it's every time in the.
Yeah.
So yes, yeah.
Yeah. So if I is the portion of cake, every time the portion is divided into half for every knife cut. So when there is no portion left, we are printing over.
Because in the problem they are not giving that scenario, exact scenario.
Yeah. So
That,
yeah.
there is a little bit confusion.
So it is like based on the mathematical operation of this cutting into half.
Yeah.
So based on that, you need to make a guess. So which real life scenario we can?
Because a student attempting alternative questions means half of the questions he might have answered. I thought like that.
No. So alternating question means, so your final value should be like uh, let's say there are 16 questions. So if you use this algorithm, it's like 16 becomes 8, and
8 plus
and
4,
then
4
8.
becomes
Yeah.
2. In that case, it is okay. Okay. It's now okay.
Yeah, so it is not okay, right? So it's
Yeah.
not.
It is not A, B. It's B, A.
So if
Because every time it is making half of.
yeah. So in that case, it's not exact. So
Till I becomes 0.
yeah. So if he's attempting alternate questions, out of 16 questions, he should be attempting 8 questions at least. But
Okay, yeah.
yeah.
Okay.
Sir, what is that option? The last metro train serving 128 station. Is there any limitations of that bits 64, 128? Any
No.
relation to that thing? 128 stations.
So this 128 stations is like, let's say
64.
this is your start station and this is your end. So in between there are 126 stations in between, like this. So this kind of it's sort of a linear search, forward and then backward. So this will be clear once in the last question. In the next two questions, there is an option with this scenario, so you can relate to it better once you see the code corresponding to it. Okay, so the ninth question is this. So this also same 4 scenarios are given, real life scenarios. So the following code to its best represents what?
Yeah, every time it doubles, I think.
Yeah, every time it's doubling. So which of these 4 makes sense?
Yeah, every time it is doubling.
So I think you kind of know the answer. So that is option 3. So every time it's doubling, and when the population becomes 128 or more, we are printing over.
That is over.
Yeah. So that is the critical limit beyond which a host can tolerate the virus count. Once it becomes 128 or more, it's no more tolerable. It's killing the person. Okay, so this is question number 10. Again, a real life scenario.
Question number? This one is question number 10.
10.
Okay.
Yes.
Yeah. Mm, maybe the hero.
Yes. So in this case, the real life scenario is metro station.
Victoria.
Yeah.
Victoria.
So in this case, if we take this is the start of the metro line, this is the end. Okay. So over here, this I is this station number. Okay. So this is I is equal to 0, and this is I is equal to 128. 1, 2.
So function it returns one.
Yeah. So the
First-
function, all it does is it is printing the station number.
Yeah. First time it will print one.
Yeah. So first time it will print 0, right?
0.
Yeah.
0.
So f is a flag variable that will decide whether the train will move backward or forward.
Okay.
Okay. So if I is equal to 0,
One.
f
Backward.
is 1, so forward.
Perfect. Yeah.
Okay. So this is
Minus 1 means backward.
yeah, f equals 1. So if f is equal to 1, function is incremented by station plus 1. So it is incrementing recursively. So our station number is incremented 1, 2, 3, etc. 127, 128. So when we reach 128, f is
It
equal
reaches
to,
28 means
now we have to turn back. So
turn back.
so f is equal to
It is backward direction.
backward direction -1. This is our flag variable.
Yeah.
So when f is equal to -1, we are recursively decreasing the station number.
Mm.
Okay, so now it will print the station numbers as 127, 126, etc.
125. Backward direction.
Backward direction until 0.
Yeah. Until.
Yeah. Okay, so this is a simple function.
Sir, 1 minute.
Yeah.
Depending on the scenario only, you have to analyze the large program. Or
Yeah. So
see, here 4 scenarios are there. No?
yeah.
How can we get the idea within a short period that which actual scenario was for this?
Okay, so one thing is you can see the limits of extreme cases. So you can check in your options whether it's 128 stations or
Because in our previous questions also 8, 9,
yeah.
the same number we have used I greater than 128.
Yeah. So it depends on the functionality. So
Okay,
here it's
fine.
doubling. Here it is exponentially we are doubling the population. So that is where exponential growth occurs, virus culture. So we have to little bit apply our real life logic also.
Okay.
So in virus culture it will multiply exponential, right? So every virus will give birth to 2 young ones.
You have to use only
Yeah.
aptitude.
So that kind of thing. So and over here it is division. So if you consider all the other 3, there is no division taking place. Virus is multiplication,
Yeah.
A student attempting is like a 50-50 chance, but it's not recursively getting half. It's just
That's okay. There is variation, no, among them. All the three are different.
yeah. So if you see the mathematical progression in every iteration, you can find a trend over the data.
Okay. That means you must very carefully observe the scenarios.
Yeah, so you just give one value of I and then see how it is getting for every call of the function, how is it decreasing. So if you give 16 in this case, it will go 16, 8, 4, 2, like that.
Okay.
Yeah, so based on that trend, you can cut off all the other obvious wrong answers. You can cut off, then you can come to a conclusion.
Mm. This type of questions also they ask in the examination.
Could be asked, because these are like this could be asked in MCQs.
Okay.
Yeah.
So it's not enough if you thorough with the fundamentals and syntaxes of pictures.
Yeah, because ultimately we would want to apply our programming knowledge to a real life situation, right?
Okay.
So let's say you are given this kind of problem. If you are
But we are not getting any moral question paper like the, that's the problem.
yeah
And actually, what we are thinking, most of us, I hope so,
yeah
that may be very related to topics or week 1, week 2, week 3 syllabus related to week 1 only.
okay. So even if you follow the weekly lectures,
Okay.
even for week 6 and all, so it's like practical problems. We are writing a code to it, and through that we are learning the programming language. So this course is defined in a way like it's not like lesson 1 syntax, lesson 2 functions. It's not
Yeah.
in that fashion, right? It's not a traditional course.
Okay, this is mostly application oriented. I think.
Yeah, this course is mostly you see some simple problems, not too much complicated. So your problem code requires
No,
like
what I am asking, suppose we have some idea so that we can we also prepare in that orientation.
yeah. So what I'm stressing is that these ideas that you need for this course, it's not too complex. It's just see,
This is not complicated.
yeah, it's
But
not.
in general, whenever we talk of the programming languages, we think that some problem will be there. We have to solve like that. This
Yeah.
general problems we have to think.
Yeah. So
Even though they are very simple.
yeah. Yeah.
Okay, sir. Okay, thank you.
Yeah, sure. So I have a couple of assignment problems also, programming assignments. So here is an assignment. So you are provided with a playlist containing n songs. Okay, so each has a unique positive integer length. Assuming that you like all the songs from this playlist, there is a song which you like comparatively more than the others. So that song is called Computing Paradox. Okay, so you decided to sort this list in an increasing order of the song's length. Okay, so we have n songs. They are of different how many minutes the song's length is. So they are randomly put in a list. Okay, so if n is 5, these are the length of these 5 songs, and after sorting it becomes like this. Okay, so before sorting, let's say your favorite song is 5 minutes long. Before sorting, it was in 3rd position. Okay, so before sorting, it was in 8th position in the index. Your task is to find the position of the Computing Paradox song, your favorite song, in the sorted list. So before sorting, it was in 3rd position. Okay, so after sorting, what will be this position? This you have to find out. So the input format is like this. First line contains 2 numbers denoting the number of songs in the playlist. Okay, and the second line contains n integers between having a space in between them, denoting the length of the songs. Okay, and the third line is that is the integer k, denoting the position in the initial playlist before sorting. Okay, so the output should be a single line containing the position of your favorite song is number what. Okay, so there is an example. So yeah, so your input, this is number of songs, this is their corresponding length in minutes, this is the kth position of your favorite song. So your favorite song is 3 minutes long in the unsorted list, it's in the second position. I'm sorry, so this will be the second position. Just a second. Okay, so index is 2, k is the index. So after sorting, this list will become like 1, 2, 3, 4. Right? Now the index of your favorite song, which is 4 minutes long, that is 3. So 3 should be printed as the output. Okay. So that is what is explained here. So n equal to 4, number of songs equal to 4, k is equal to 2, the position of your favorite song in the unsorted list, that is 2. Okay, so that's what I have circled here. I'll do it here too. So after sorting, your favorite song is here, that is the third index. So your answer is 3.
పత్లి అంటే
మోటి పతిలి మోటి
మరి లంబా అంటే తప్పు రాసినావు కదా.
Can you mute yourself? Thank you. Okay. So I hope the logic is clear. Try solving this assignment. Let me know if you have any difficulty. Yes, so I'll share the model solutions with you. Okay, so one of you had shared the solutions. So L is this, K equals input. Okay. N of K minus 1. Yeah, so this snippet seems to be right. I have a similar solution here, so which essentially does the same thing that one of you had shared in the chat box. So we are inputting the number of songs captured in the variable n, and the list A containing the length of each song is given, and so K according to the problem definition is it's the kth position in the playlist. Okay, so you have to be careful with k position and kth position and k index. So if if the song is in the kth position, so its index will be k minus 1. So its keys of the array A k minus 1. So the favorite song key is captured here. Okay, then sorting of this array is performed. So for I, there is an iterator I that we take for comparison. So if this, so after sorting, so this just converting all the small a's and capital A's. So for each element in the sorted array, we are checking for this key. Okay, so this favorite song value is captured here, the length is captured here. So we are just searching for each element in the sorted array. We are doing this kind of search. So if this is A of I is equal to the favorite song length, we are printing that index. So I plus 1, if I is the index, the position will be I plus 1. So we are printing that I plus 1. Okay. So one of you had, Bharat has he has done the same kind of thing, but it should be in a loop. So we would L dot index of, okay, so index of favorite song. Okay, so this also can be, yeah, this also is fine. So this is another way of doing. So what I had done instead is I took the value corresponding to this position key. So I store in the key variable, I stored the length of my favorite song. Then in the sorted list, I'm comparing that length in the sorted with the each song length in the sorted array. Okay, so when I find this equality satisfied, I'm printing out the index plus 1. That will be the position. Okay. So that is assignment 2. Simple sorting problem. So assignment 3 is here. So this is also a simple programming assignment. Okay, so the input format of this program is that we are taking a number n in a single line and printing. Okay, I think I'm missing some definition here. So try assignment 4. We'll come back to assignment 3. So given an integer number n, define a function named print a dictionary, which can print a dictionary where the keys are numbers between 1 and n, both included. The function print dictionary doesn't take any argument. Okay, so the input format is in this form, contains the number n. Okay, so that is the number of keys in the dictionary. Output is just print the dictionary in one line. An example is given. A dictionary of 5 keys is given. Input is 5. Output should be that for each key some values assigned. Okay, so the value is such that it is square of the keys. Okay, so this is the catch. So if my key is 1, 1 square is my value. Key is 2, 2 square is my value. Key is 3, 3 square is my value. Okay, so this sort of output array should be printed. So this is simple enough. We're just playing with the index. Okay, so I hope this is clear. So try this question and then let me know.
So take the
Yes. Yes.
dictionary. Show the dictionary.
Your voice is kind of breaking. Okay. Can you repeat?
So using loop, we can take the keys and square the corresponding value.
Yeah, so corresponding to each key, the value is square of the index.
That is, you can use a for loop.
Yeah, for loop is the way to go. Yeah,
For loop you can use
yeah,
and keep the value as it is. That is key value. Keep the as it is.
yeah.
Key
So,
you have to keep the as it is, and corresponding value you have to make spare it.
yeah. So I'll give you a clue. So it's like it's like for the for loop will run from
What? Yeah.
Yeah, I'm typing here. Is it visible? So for I in range,
For I in range.
1 to n plus 1. Okay. So when this is the range, all we have to do is so if k is the value, k at ith index should be I times I. That's all. So this should be the logic. Okay, so basically this is the logic. So I'll show you the solutions as well. Okay, so yeah, here it is. So we are defining a function print dictionary. So that is taking in n is the number of keys, d is initialized, dictionary is initialized. So in the range of each element, we are just squaring the index. So this double asterisk is exponentiation. So you can do this operation. Okay, so for each value corresponding to an index I, the index is squared up. That's all. We are printing the dictionary D after this assign, and we are calling the function. That's all. Okay, so it's pretty straightforward.
So if the numbers are not in sequence, then what we?
If the numbers are not in sequence,
How can we do it?
so this I is just the
Up to n now. So okay. So 1, 2, 3, 4. If you take like
yeah.
I have also initialized dictionary. So between the dictionary.
Yeah, so this is just the index, right? Key value. So
Okay.
I is the key, so it will be in a sequential manner. Yeah. Okay. So yeah. So this is the solution for assignment 4. So assignment 3, I have. So assignment C 3 is same as assignment 4, just that here you are calculating cubes of each now key. Okay, over there we are calculated squares. Over here it's just the value will be cube of this key value. Okay, 2 cube is 8, 3 cube is 27, 4 cube is 64.
Okay. 125.
Yeah, 125, 216, and so on. Yeah, this is 6 cube, 7 cube, 8 cube.
Okay. The same program you can make the
Yeah,
modification.
same kind of problem. Just that in this question, we had a function definition. We had to call the function. Over here, it's assignment 3 is much simpler. There is no function definition. We can write the logic in the main code itself, and we are calling that. So I'll show you that also. So since it's same logic, we can just go through the solutions. Okay, so n is the number of elements in the dictionary. Dictionary is initialized.
The dictionary is also not required in that case.
In this case, so we wanted a dictionary is not necessary. We can do it in a list format also.
Yeah.
But the question demands us to create a dictionary, print a dictionary.
Okay.
Yeah. Otherwise, we can do in list also. It's just a simple operation. But dictionary is good in the sense we can keep track of what we had done. To access the previous operations, what we had done. For that purpose, dictionary is a good record.
Yeah.
Yeah. So
Because we can get the corresponding square and corresponding cube.
Yeah, it's very easy to extract values.
That is it.
Yeah. Okay, so that's all we had for today. Okay, so these materials are available in the drive folder that I had shared with you. So anytime you can follow that and follow the YouTube channel also if you have any doubt. Okay, so alright then. So we'll see you next week. Okay. Thank you.